Okay, so for average rate of change, we just do the typical slope formula, which is change in distance over change in time, change in y over change in x, okay? What if we wanted instantaneous? So rather than an average between 2 points, what if we wanted at a single point? And this is where we transition from the concept of finding the slope of the secant line between 2 points to finding the slope of the tangent line at 1 point. And so what they're saying here is exactly what we know. We've already done this before. This is the definition of derivative. Of course, they use delta x, and I like the h version of it. So this is the limit as h approaches 0 of f of x plus h minus f of x all over h. Exact same formula, just not using the delta x. Again, I don't care which one of those you use. So this is now the instantaneous rate of change, which is also known as the velocity at a point. So what do we have? We already have numerous definitions for a derivative, equivalent meanings or interpretations of a derivative. We know it's the slope of a graph at a given point. It's the slope of the tangent line to the graph at a given point. It's called the derivative at a point. It could be the instantaneous rate of change, or it could be the velocity. If anyone asks any one of those 5 questions, they're asking for the exact same thing, which is equivalent to the derivative. So it says, we know this definition right here, the limit definition, but now instead of doing the full limit definition proof, we can use the tricks that we already have for derivatives to help us determine instantaneous rate of change or velocity. So we don't have to do the limit as h approaches 0. That's just how it is defined. So this is the height of a fallen object is given by negative 16t squared plus 180. This is the same object on the previous page. Just to let you know that negative 16 comes from gravity. This is measured in feet per second. And that 180 comes from your initial height. So what this would represent is dropping an object off of a 180-foot building, so to say. Just hold your arm out at 180 feet above the ground and let it go. We can, because gravity is constant on every object, if there was no wind resistance, this would be the exact formula at which it would fall. So this says find the velocity function of the object. So if the position function is s of t, then we have the velocity function. Velocity function is v of t, which is equivalent to the derivative of, let me redo that, sorry, the derivative of the position function. That's how we find the velocity function. Well, that's really easy to do. The velocity function then would be the derivative, which would be, well, the derivative of negative 16t squared. Negative 16 is our coefficient out in front, and then we take the derivative of t squared, and that would be 2t raised to the first power, plus the derivative of 180. 180 is a constant, and the derivative of any constant is 0. Simplifying this, our velocity function would simply be negative 32t. Negative 16 times 2 is negative 32t. So this is our velocity function. Velocity function would be negative 32t. Again, remember a derivative is a slope. So I want you to think about what's the input and what's the output. Here, if we want to find the velocity, it's the change in position over the change in time. That's what velocity is, change in position over change in time at a single given point. Change in position here was measured by feet. Time here was measured by seconds, so this would be any number that we get would be feet per second. So it's negative 32t, but the units, and in every applied problem we have to label those units, would be negative 32t, whatever that number is, feet per second. So now let's look at this. It says determine the velocity of the object at t equals 1.75 and t equals 2. Anytime I'm evaluating a function at multiple points, I love using my table feature on my calculator yet again. So here we're going to plug in t as 1.75 and t equal to 2. We look at our velocity function. We know that we found our velocity function to be negative 32t. So what I'm doing is hitting the table feature on my calculator, clearing out the function that's in there, typing negative 32 and hitting that X button. I hit enter. I don't care where it starts. I don't care what the step is. Just make sure Ask X is selected. Hit OK. Go ahead and type in 1.75, hit enter. I'm getting a value of negative 56. Type in 2, hit enter. I'm getting a value of negative 64. So what is my velocity after 1.75 seconds? The answer would be negative 56 feet per second. So velocity also carries a direction. What does the negative mean here? This means that it's traveling downwards. This does not mean the velocity, the speed of the object is decreasing. This is giving us a direction that the object is traveling. So it is traveling downward at a rate of 56 feet per second. So after 1 second goes by, it should travel 56 feet further. At 2 seconds, it is negative 64 feet per second. So there's our labels right there for you. We have now found the velocity of the objects at those times. Notice, as time goes by, the object starts moving faster and faster and faster. Again, this would be true until terminal velocity is reached.